The galaxy M100 is so far away that if beings from there were to look at Earth right now, they would be watching the real-time extinction of the dinosaurs. As a physicist, what do you find the most fascinating about time and space? All right, I think that's an excellent question. And before I give you my opinion about what I think is the most fascinating, let's think about what this person said in their question, right? They said if aliens were looking at us, they would in fact see us at an earlier time, right? They could be looking at us so far back that the dinosaurs were still roaming the Earth. And so it's kind of weird to think about, but anytime you look out at the sky at night and you see a distant star, you're in fact looking back into the past. Why is that? Let's take a simple example of looking at our sun. Okay? Our sun is a star. It's our star, so we call it the sun. And there is light that is propagating from the sun all the way to us. But it takes a little time to do that, because it has to cover a distance, d, which is about 93 million miles. And it is moving at a speed v. Light is pretty fast, but it's not infinitely fast. For a long time, people thought it was infinitely fast. It's not infinitely fast. There is a finite number that goes with the speed of light. We call it c. Anybody know what that is? 3 times 10 to the 8 meters per second. It's actually 2.9972, blah, 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 blah. We say it's 3, close enough, all right? How much is that in miles? I just told you this distance in miles. How fast is this in miles? It is 186,000 miles every second. Okay, light's moving pretty quick. Not infinitely fast, but pretty darn quick. Just about the fastest thing that we can think of, right? That's it, speed of light. 186,000 miles per second. Let's put that into perspective. If I go once around the Earth, that's about 25,000 miles around. So if I turn on my flashlight for 1 second, 1,000. It could go around the Earth on the order of 7 times in just 1 second. Okay, it's moving pretty quick. But from the sun to the Earth, that's 93 million miles. So how many seconds does it take? Well, it's moving at a constant speed, and so we can say that distance equals rate times time. If I want to solve for the time now, time is distance over rate. I've got 93 million miles, which is 93 times 10 to the 6 miles. And I've got c, which is 186,000 miles per second. Okay, what is that? Let's approximate it. 93 times 10 to the 6 over 1.86 times 10 to the 5. And 93, oh, this is pretty close to 2, right? So this is going to be 90 over 2, which is about 45. And I've got a 10 to the 6 over 10 to the 1, so that's 10. And so I get t approximately 450 seconds, which is about 7 to 8 minutes. That's how long it takes light from the sun to get to the Earth. Okay? So it's kind of weird to think about, but even looking at the sun, we're looking back in time. When you look at the stars that are much, much further away, of course, you're looking very far back into time. But there's a problem here, which is, what do we really mean by looking back in time? Okay? Because there is, in fact, no universal clock. There's no clock that exists for the Earth and the Sun and all these other stars that tells us the universal time. Everything is related. The entire universe is not space, and it's not time. It is, in fact, something called space-time. And so when you hear physicists talking about that, space-time, that's what they mean. Everything is tied together by this speed of light. I'm not really looking back in time, I'm looking across space-time. And that's kind of the neatest thing to me, is that you can't really just talk about space. You can't really just talk about time. You, in fact, have to talk about something called space-time. And a lot of this was due to Einstein. And so his theories of relativity deal with this notion of space-time. And when you have massive objects like black holes, they put a dent, not in space, not in time, but in something called space-time, which is a combination of the two. And I think that's pretty cool. I might have told you the old joke, but I'll tell you again. One of my friends who's an aspiring actor, he said, you know, when you wish upon a star, it's not really quite right. That star has been dead for millions of years already, just like your dreams.